Good morning, everyone. Hope everybody's doing good out there. My name is Jonathan Girardi, and we're going to be going over the new Night XL intro, going over some of the new things that we updated on the new Night we just released. A lot of pretty cool information going on that we're going to be talking about during this webinar. Going to try to stick to making this last right at an hour. I know on the last on the webinar we did this past Tuesday, we had quite a few questions, so we went over a little bit. So if we go over, I do apologize, but I don't like to short on information when we get on a roll or we get questions going on. So please, you have the ability to raise your hand and I can allow you to talk and we can talk about certain things. Or if you'd prefer to just shoot me a quick message, and I'll be happy to just to shoot you back a quick message. I will warn you, sometimes I don't see those messages right away because I'm on a roll talking about a heat exchanger, talking about something, so just because I don't immediately get back to you doesn't mean I'm not. I definitely will. So don't be afraid of that. Also, if you know someone who wasn't able to make today's webinar and wants to rehash some of this information, or you do yourself, you're going to have that ability on lochinvaru.com. That's our online training website. We have a Zoom section that we've been doing through all this whole COVID mess. So we've got several recordings of a lot of different topics, not just this one, several other ones on there. So if you want some other information, you can definitely find there. Again, my name is Jonathan Girardi. I've been with the company about 7 years now, and we started doing something a little bit different the past couple of webinars. We're actually having, 2 or 3 people on our side, 2 or 3 trainers on our side, kind of doing it. I don't want to say podcast style, but you'll hear Kevin Watts, who is here with me, chime in. Say hello, Kevin.
Hey guys, how's it going? Like John said, my name's Kevin Watts. I've been here going on 20 years next month, I guess. I mean, it's 20 years. That seems like yesterday I was learning how to, never mind.
I'm trying to remember what grade I was in 20 years ago. How old are you, Kevin?
92.
Back when the rainbow was in black and white, you started Lochinvar, didn't you?
Yeah. Yeah, this webinar is going to be a little bit different than our other ones. Like I said, we're showing the differences of the new Night XL. So if John or myself gets to a slide and we didn't go major in depth on, let's say, a gas valve, which is a good example. The gas valves for these particular models are going to be the exact same as the gas valves as far as how they work. It's going to be the exact same as on the old Night XL. And we've already got videos for those. And if you want to know more in-depth knowledge on certain items, just go to that video for that older product that we have. And that goes for any product that we have out there. We have quite a few Zoom meetings out there.
Several out there.
So, but again, don't be afraid to ask any questions. Just type them in or raise your hand and we'll unmute you and you can talk to us.
Yeah, absolutely. Like he was saying, if this was a normal in-house class, we would spend a lot more time on a lot of the different subjects that we're going to go over today. And you'll probably realize pretty quick, I'm real bad about going into Pandora's box and really getting in depth. So sometimes the other trainers have to pull the reins back on me a little bit so it don't take too long. But hey, I just like to get the right information out to everyone and make sure everybody's on board. So again, if you have any questions as we're going through this intro, feel free to shoot me a message, raise your hand, and we'll definitely talk about it, okay? So absolutely. We'll get going. So let's start out with just a little bit of history about the Night XL. In 2005, we came out with the first Night, the 400 and the 500,000 BTU models. And it was a great unit. I mean, that unit took off. It was that was right after we first got into condensing. So our efficiency levels were right in the mid 90s, 95, maybe 96% efficient. And we're going to talk about how we achieved that here in just a little bit. You can see in 2007, we did a little bit of, we didn't do an upgrade. We just came out, we extended that line. You see that the 6, 7, and 800,000 BTU models were introduced. And it was a great unit. I'm sure some of you have probably ran into those. It was just a water tube style heat exchanger with a push button interface. A couple years went by and we did a small upgrade to it. Pretty much all of the internal mechanisms inside of the unit, parts, all that stayed the same. But we changed the control a little bit, so you had a lot more capability as far as fitting that product into, different applications. So things like that. A little bit easier interface to get into. The scroll knob came out instead of the push button. And 2015, we did implement Connexus on there. So, you know, if you're not aware of what Connexus is, you can be anywhere in the world as long as you and the unit are connected to Wi-Fi. You can change parameters, monitor it, things like that. You know, you can it can actually send you an email or a text message saying, "Hey, I'm locked out," or "Hey, I'm doing this," just in case something does happen. So that's what Connexus is in a nutshell. And this past year, we just released the latest Night, right? And we're going to go into the big differences. I'm liking this product so far. It's we're still using water tube design technology, and basically, the big thing that everybody's going to notice when they first walk up to this unit, yeah, we did implement a touchscreen on here, but here's the thing. If you understand and know what all the parameters do and mean in the KBN series, you're going to be able to understand the KBX series, which is what we're calling this newer Night that we came out with.
Yeah, I agree. I mean, I don't know if I can think of one parameter that is different. It's just there might be one, but off the top of my head, I can't think of one parameter that's going to be different between these the last series Night XL and this series Night XL. It's just a touchscreen. That's all it is. And if you're familiar with our other product like the Power Fin or the Crest or the Armor, the larger Armor, it's basically the same touchscreen except in a 16:9 ratio aspect. So,
yeah, I think the only thing that, you know, when I was breezing through some of these screens that was different is you've got the capability to have a redundant leader. But if you're used to the AWH, the larger Armor, or the Crest, you know what that is. And if you have questions about that, we can go into it. I'm not really going to go in depth with that, but yeah, SH1, SH2, SH3 are all there. It's just touchscreen. So, and you're connecting to Wi-Fi, which you were if you had Connexus anyway. So
right
on the KBN. So these are a couple of the big things that are changing a little bit. We brought that efficiency level up a couple points from right around 95 up to 97 thermal efficiency. Instead of having a 5-to-1 turn down, we did upgrade to a 10-to-1 turn down. So that's really going to help power those micro zones to really keep that unit from short cycling, because as we know out in the industry, if that unit is cycling coming on and off more than 6 times an hour, that's considered short cycling. And all those parts have a life expectancy, a cycle expectancy. So the less we're cycling, the better off that we are, we're going to go. So do keep all that in mind. The KBN was able to be vented up to 100 equivalent length. So we add an extra 50 feet to that. So you do have the ability to vent 150 equivalent feet as well as the intake. Okay. So do keep all of that in mind. If you're, if you have some long runs, you have to overcome. Okay. Again, we talked about the Smart Touch LCD that we integrated into this model, so I'm not going to hit on any more of that. Now, we do still have the outdoor model still available. One thing I do want to point out here is the indoor model cannot be converted to the outdoor model. Okay.
Could you repeat that, please?
The indoor model cannot, I repeat, cannot be converted into an outdoor model. So if you order an indoor model and you want it to go outdoors, I don't know. It's not going to happen.
It's not going to happen. Yeah.
It's not going to happen.
I don't know about it. Yeah.
Build a mechanical room and put it in there somewhere. So, and we do have a good shot of the outdoor model at the end of this presentation that you guys can check out. The outdoor model looks exactly like the large Armor that we came out with back in like 2015, 2016, if you're familiar with that. So you'll see a picture of that. So don't worry.
Yeah.
Cannot be converted. All right. So the main section here that we're going to be talking about today is what's inside the box, the parts and pieces, how it's all working, this, that, and the other. Okay. So keep that in mind. And again, ask questions if you have them, and we'll get going. First thing I do like to talk about is just the heat exchanger itself. So this is kind of the heart and soul of the unit, right? This is where all the good efficiency levels are coming from. This is where all your heat transfer is happening. Let's just talk about, the word of the day when we're talking about this heat exchanger. Let's talk about condensing just for a second. So a lot of people think that we get those upper 90s percentile efficiency levels from modulation. Hey, I've got a 10-to-1 turn down and I can modulate all the way down to 10%, anywhere in between 10% At 100%. Now, are we more efficient when we're using a little bit less gas? Absolutely. Yeah, that's saving you money in itself. But when we're talking about efficiency levels as far as a Lochinvar standpoint, we're not talking about modulation or combustion efficiency. We're talking about thermal efficiency. How much heat are we actually driving into the water? And this heat exchanger allows us to get up to that 97 percentile. So here's how we do it. Condensing. So there's a certain number I like to throw out there that enables this unit to start condensing, right? And that number's right around 140. I think it's actually like 128. But we throw 140 out there. That's just kind of the number we've been sticking to. So if you start to return water to this unit less than 140 degrees, you're going to start to cool those flue gases down to where they start to condense. It causes that gas to turn into a liquid. And as that transformation happens, that phase change, we gather more energy from that phase change actually happen as heat. And we put that heat back into the water. It's extra energy is what's produced out of that phase change, and that's how we start to increase that thermal efficiency. If anybody was wondering how it worked to get down to the nitty gritty, and that's another reason why we have to be stainless steel. In fact, we're 316L stainless steel, so we had to have a certain material to withstand that acidic flue gas condensate, because that stuff it's pretty acidic. And to give you just a chance to kind of see where I'm coming from. We're around what about 3.5 on the pH scale, Kevin, as far as that condensation?
Yeah, pretty acidic. Yeah, it's going to be on the lower end of that pH. So, yeah, it's pretty acidic.
And we'll talk about how we get rid of all that condensation here in a little bit. And that's why you're never going to see. That's why on our non-condensing units, they're made of those heat exchangers they're copper material heat exchangers. So you always have to get that water temperature at or above that 140, so they don't condense and they don't rot that, or basically eat away at that copper heat exchanger. So do keep that in mind. That's why we're 316L stainless steel. You also see that the little bullet point or the little hyphen, no O-rings or gaskets. And, think to yourself, why is that a good thing? There's no O-rings, there's no gaskets internally of this heat exchanger. Well, it's been my experience that gasket is most likely the weakest link in something. And when it gives up, hey, you're done. So we thought it would be a good idea to always try to go with heat exchangers that didn't have those type of gaskets or held on by bolts or anything like that. So we're not going to worry about anything leaking inside of this. Now, on a flip side, I don't like to start on a bad note, but I do like to make everyone aware if for some reason we get a pinhole in a water tube or something like that inside of this heat exchanger. Maybe there was a big leak in the boiler system, which should be sealed, and somebody just hasn't caught it, and we're constantly adding a lot of fresh water that has not been treated into the system. If you've got a lot of minerals, a lot of calcium, magnesium, that's your hardness, so we can actually start to scale up at that point in time. And unfortunately, we have seen heat exchangers that have gotten scaled up. And here's the deal: we're real good at putting heat into the water, but we need certain flow rates and velocities of water going through these water tubes to keep that heat exchanger cool. It's a back and forth process, right? So if you do get a hole or some damage inside of this heat exchanger for whatever reason, that there's no welding, there's no brazing or anything like that on these water tubes, I'm going to recommend you do get that heat exchanger replaced. So do keep that in mind, as you're going through there. Okay. All of these units are ASME certified, so they're going to have that H stamp that you're probably familiar with. The maximum operating pressure of this pressure vessel is 160 PSI, pretty much like everything else that we have to offer out there. But what, I kind of like to touch on the ASME and what that means. So when this heat exchanger has been welded up and they're testing it to make sure it doesn't have any leaks, at the end of the line, they're going to test it at 1.5 times that 160. So they're already putting 240 PSI to this unit. Now, ASME dictates the design pressure has to withstand 5 times the amount of the working pressure. So I think 5 times 160 is right around 800 PSI. So every now and then we do have somebody from ASME come into our facility, pick one of these heat exchangers and see if it can pass that 800 PSI. If it does, which it will, we're good. But if it doesn't, we've got a huge issue. So, and to my knowledge, we've never had any issue like that before. It's been pretty straightforward. Something else I do like to show while we're viewing this picture on the left, if you can kind of follow along, you can kind of see my mouse. This is where you will be doing your heat exchanger and burner cleaning from. So this is something that I really like to kind of hit on. Heat exchanger and burner maintenance are probably the two of the biggest things that I preach out there, because you know you deal with flame failure all day long, flame failure ignition, flame fail running, burner harmonics, unit not lighting. 9 times out of 10, that unit's been installed for a while and nobody's taken the time to just get in there and clean things up and make sure it's been done. So once a year, I'm going to ask you to remove that front door. You can see those pretty heavy duty bolts here that are holding it on. And later on, we're actually going to have some training videos come out to show you exactly how to take that apart, because we do it a little different up here. You know, we don't want you just going to YouTube and watching, you know, Joe Blow rip a unit apart or anything. We want to try it the right way. And we've tried to take these units away, take them apart in different ways. So we found the most efficient way and quickest way to do it. Right. So do keep all that in mind. You will eventually pretty soon see some of the training videos on this unit on Lochinvar U. So once a year, I want you to take this front cover off, take the burner out, and with the real stiff nylon brush, and we do offer service kits out there. It's basically a little it's a little circular wheel brush that's nylon, that's got a couple of drill extensions with it. I just want you to go in there and really get in between those water tubes if you see any debris in there. And it doesn't hurt to take a vacuum afterwards and kind of pull some of that debris out, as well as, you know, take a low pressure water hose in there and disconnect the hoses from your condensate trap and route that to a drain, just to make sure we get all that debris out of there and everything's fresh inside of there. Right. So once a year, I do want that done. I'm not going to discuss burner maintenance at the moment. We've got a section later on coming for that, but once a year, I do want that done. And not, you know, just because the unit's running fine doesn't mean it doesn't need to be done. Okay. Because I always relate that back to car maintenance, changing the oil. And you notice I say oil and not oil. That's that redneck accent, right, Kevin?
Yeah, we all got it down here.
Yeah, we can't help it. We can't help
suffer through it.
Yeah. Sorry, guys. They're probably laughing at us right now. These guys sound like idiots, you know. But anyway, so just an FYI on that. So talking water tube design, meaning the water is going through each one of these tubes. Got a couple different passes going on here. The KBN, oh, it looks like we got, let's see here. Looks like we've got a question here. How do you clean the micro channels inside the heat exchanger with the nylon brush? So here's the answer to that. So those tubes inside that heat exchanger, they do flex a little bit to kind of prevent from any type of thermal shock. They expand just a little bit. So those tubes do flex just a little bit. So if you get a very stiff nylon brush, I don't mean like a soft one like you would brush the floor, you know, brush like a broom that you would brush your house out with on your kitchen floor. These are going to be more stiff. So they're actually going to cause those water tubes to move just a little bit, and they're actually going to get down in those channels. Okay. And that's also where that water pressure kind of comes in. Low pressure comes in to kind of wash any of that stuff out. So does that answer your question, sir? Shoot me back a yes if that does. Excellent. Good deal. Moving on. All right, so you see there's no V-baffles or spacers in here, and again, we just kind of discussed how these tubes will flex. Back to our condensing, you can kind of see what's going on in that bottom picture, how it's basically kind of raining inside of that heat exchanger. So that's what's happening inside that heat exchanger when that return water temperature is, you know, below 140. So if you're cruising at 110, returning back to the unit, you're grabbing that 97 percentile of efficiency. So you're definitely saving money there for sure. Now, one of the differences between the KBN style heat exchanger and this KBX style heat exchanger, the New Night, is on the top picture, you can see that we have a double row. Okay, we've got a double row of water tubes, where on the KBN, it was just a single row through each barrel of the heat exchanger. So as that latent heat is floating around in there, it has more of a chance to really transfer back into the water. Okay, let me see, I think I had. I see. Hey, that's a good point. So
Yeah.
we had a comment here about the getting in between those little channels inside of the water, or in between the water tubes. And I had a guy say that credit card works well between the tubes as well. Yeah, I don't have any problem in there. Just make sure you don't lose your credit card.
Yeah, I've heard of a lot of people doing that. That instead of using a credit card, they'll use like an old rewards card or something like that, because the last thing you would do is damage a credit card. But unless you just steal it from your wife or significant other and don't want them to spend anything else anymore. But had a couple comments like that in the class, like, yeah, I just stole my wife's to take it away from her, so I use that credit card now. But yeah, I mean, that does it's a little time consuming, but it does work. But there is another question on here saying, does Lochinvar suggest using any type of cleaner? Honestly, we've had this question in the past. Can we use water or a cleaner on the heat exchanger? And the answer is no, we don't mind. We don't mind you using water or heat or any type of cleaner on the heat exchanger. Anything that's just not going to hurt stainless, which is honestly pretty much anything. We can't recommend a type of cleaner because, we do work for Lochinvar, and that's kind of like us promoting it. But yeah, we have seen people use cleaners before, but I will say there's a fiberboard piece in the back of that heat exchanger that you would need to get out first, because that fiberboard piece is to protect the back side of the unit from overheating. So therefore, you want to make sure that doesn't get wet. Any type of fiberboard insulating piece, if it gets wet, it starts to deteriorate and shrink, and you could cause damage to the heat exchanger itself. So you want to get that out first, so you don't get it wet. But yeah, we don't have a problem if you using any type of cleaner that's going to be safe for stainless. And we'll get into, when it comes to the burner, because that's a different subject. We'll get into cleaning the burner a little bit later.
Yeah, absolutely. Kevin, I always think it's kind of a good idea on whatever cleaner you're using. Just after that, take just some straight water just to kind of flush that cleaner out.
Yep.
Let it run out the condensate trap itself. Kevin mentioned the refractory in the back of the heat exchanger. There's also another refractory that's attached to the front door, so we don't warp the front door or anything like that. So again, same concept goes for the front door. If you see it, here's the thing: when you pull it out, and over time, after it's been maintenance a couple of times, you're going to see some scratches, some little small nicks here and there on it. That's okay. I don't have a problem with that. But if I see chunks falling off or giant cracks, that thing needs to be replaced before we put that unit back into operation. And sometimes I do have the question, well, how cold is too cold returning back to the unit? And here's the answer. I mean, as long as you're not returning ice water, slush back to the unit, I'm okay with that. It's just going to promote more condensing. Therefore, you're going to be more efficient. Okay, so here's a good cutaway of what we're working with here. I do like to make this known. If you were used to the AWH, our large armor, the 1.25 mil up to the 4 million came out with a couple years ago, you're used to those Victaulic style quick connects that were on the back of the heat exchanger that you were probably quick connecting to a sweat connection or what have you. Okay. So the only out of these models, and we're talking the 400, 500, 650, 800, and 1 million, that's a new line of Knight armor that we have now. The only one that is utilizing that Victaulic style connection on the outside of the unit is the 1 million BTU model. And the reason for that is that's once we bump up to the 1 million, we need a little bit more water flow at certain velocities. So we had to bump the pipe size up to 2.5 inch. And for some reason that's the sweet spot at the end of the line when we test all of these units at 2.5 inch. We had to go back to the Victaulic for our testing procedures up here to make sure everything goes smoothly at the factory itself. But for those smaller models, the 800 and below, you're good. You have straight sweat connections coming out the back of the unit. And you can also see every model, if you can kind of follow along with me, we're still utilizing those Victaulic connections on the top of the heat exchanger, internal of the cabinet itself, but not outside. Okay. So another difference from just the all-around look of this unit is instead of having piping connections on the side of the unit, we have every connection coming out the back of the unit. Okay, so here's the deal. I'm not trying to promote this because I'm a service guy, but sometimes we have those real small mechanical rooms, and they a lot of people like the zero clearances from combustibles on the left and right side, so they can, put them really close, if not just about touching one another.
Oh yeah, it promotes the unit really well. I mean, it's a great seller that you can put these units right next to each other, like the majority of the rest of our units. But like John said, as we're service guys. If you ask me, if you ever call us up and ask me how much service or how much clearance you want around the unit, I'm gonna say as big as you got. So give me 36 inches around, because I'm the one that's gonna have to work on these products out in the field. So, but if you want to, slap them right next to each other if you need to. I mean, that's why our marketing department and our sales department, that's why we come up with these things to make them sell a little bit better for tight connections or tight space in rooms.
Yeah, absolutely. I'm like Kevin. I like as much, if you ask me, give me 8 feet around every unit in there, but we know that's never going to happen. But, you know how it all works. You've been in those situations. We're all service people here. Again, I'm not going to read each one of these boxes. You guys are more than capable of seeing what all these connections are. But again, I just kind of like to point out in this section, everything's coming out from the back of the unit. But one thing I will mention is right between the vent collar and the heat exchanger drain, you see this panel that can be removed. This panel will have to be removed to remove the flue sensor and grommet to do your combustion test on startup or when you convert from natural to LP. And don't ask your natural to LP questions yet. We've got a slide coming up, or do if you want to, either way. But we'll definitely get to conversions and how all that works as well in this presentation as well. But I just like to note that one time, and you'll see another picture of it later up coming on throughout this presentation. Okay, so let's fall back to that condensation that we were talking about earlier. So we mentioned that we were talking about a somewhat acidic liquid coming out of this unit, around a 3 or 3.5 on the pH scale. So if we're burning at temperatures, we're turning the unit around 110, you're condensing quite a bit, and it's going to be pouring pretty good out of the back of the unit into that condensate trap. But we had to have a way to make sure that when that unit is not condensing, so those return temperatures are up above 140, that we're not pouring flue gas out into the condensate trap and potentially out into the mechanical room, because we all know that's a huge no-no, right? So here's what we did. We came up with this style of trap, and we've been utilizing traps similar to this. So this is not really anything new. But the way this works, if you were to take it apart, if you were to take the top off of this little condensate trap that we have circled here, you'd see a small ball in front of the drain, the outgoing drain of the condensate trap. So what happens when you're condensing is all it does is it causes that ball to float up a little bit, and it allows that liquid, that condensation, to drain out of that trap. Okay. So if you're not condensing and you do not have any liquid inside of the trap, you're not going to be bleeding flue gases out into the mechanical room, because that ball is going to prevent them from exiting that trap. Okay. So in saying that means that trap does not have to be pre-filled like some traps on the market and some traps that we do offer. But I will tell you, at least once a year, I want you to take the top off of that trap, and I want you to look at the inside of it, because every now and then it's been known, because of the acidity of that liquid coming out of there, it can form almost like a silky substance that's caused that ball to not float like it should. And if it does not float like it should, it's not going to allow the liquid to exit the trap. Therefore, it's going to eventually pool, and it's going to pop a float switch, causing that unit to lock out on a block drain switch. So we're going to stop the unit if you get a block drain situation. We're just open and normally close contact on that switch, saying, hey, unit, I don't need you to operate anymore. Lock out on block drain switch. And you're going to see this come up on the screen. So we're not, the unit's not going to flicker the screen 3 times and make a weird sound when it's locked out on this. We're going to tell you any lockout that the unit's experiencing. So, don't worry about that. You still have actual words that are telling you what the lockout is on the screen itself. So do keep that in mind. Now, pretty much in most places, it is code that you do have to have a neutralization kit, which you can see that we've pointed out here. I think it's still listed as an option, because you've got those 1 or 2 places that still don't require it. But I'm always going to recommend that you do slap one of these on there. just again, as the picture states, make sure that that condensate trap is sitting a couple of inches above that neutralization kit. So it's going to influence that liquid, that condensation, to drain into that neutralization kit and not backflow, right? So do keep that in mind. Sometimes I get the question, well, John, how do you maintain that neutralization kit? Well, you know, you got a couple of options. The recommended option is just to take the kit apart, pour the calcium carbonate rocks out of it, and just you know, get a hose and wash the kit out, make sure we don't have any of that mess in there. I mean, I know some people that just will pour new rocks in there, and that's okay, but I like a good washing to go on and then new rocks to be put in. Sometimes I get the question, you know, well, how often is that going to happen? How often does that need to be done? Well, really depends. I mean, if you're condensing heavily 24/7, you know, just have a look at it once a month, and what you'll start to see is those rocks will start to change colors, whether that be a red or a brown color, and they'll start to slowly deteriorate over time based on how much you are condensing. But you know, if you've got a more high temp application out there, a high temp system, and you're not condensing a whole lot, so that means those water temperatures returning the unit are you know, 150, 160, then you're not going to have to replace those rocks as much, but it's still a good idea to, you know, at least have a look and see, you know, what's going on. Because here's the thing, if you don't use a neutralization kit and you drain straight into like a, you know, a cast iron drain or something like that, it's going to eventually eat away at that drain, you know. So do keep all that in mind as you're going through this. We want to protect the unit as well as anything the unit could maybe affecting.
Yeah, I agree. I mean, that's neutralization kits are so important. And a lot of people don't think that they are. I mean, but I guarantee you that neutralization kit's going to cost a lot less than you having to jackhammer drains up out of concrete. So these units can condense. You know, I don't know if John said it or not, but you know, these units can condense quite a bit. You know, the rule of thumb is 1 gallon an hour for every 100,000 BTUs that you have. So that means if you have a 1 million BTU new Knot XL here, that means it can condense 10 gallons in an hour at fully condensing levels. And if you take that all the way, if you're used to the rest of our product line, if you take that all the way up to the Crest 6 million BTU model, if you have that model and without a neutralization kit on it, I mean, you're putting 60 gallons an hour, possibly 60 gallons an hour into that drain, which is not going to take no time with the acidity of the condensate there. So, I mean, it's just worth the money, whether code requires it or not. And, you know, me and John, we're not in the business of selling these products. I think what we do actually does sell the products. We get into more the technical side, but we're on the service side as well. And the last thing we want to see when we walk into a mechanical room is condensation everywhere where we can slip, or drain starting to be eaten away from that acidic condensate. So it's worth it. Trust me.
And it always looks good on a nice install job where everything's, you know, nice and neat, and you don't see drains rusting away or pools of water everywhere. So, you know, I like those good clean applications out there that are installed. Let's see. It looks like we've got one question. Is the switch replaceable? So the actual switch inside of the condensate trap is not replaceable. So if something actually happened to the switch inside and the mechanism failed for whatever reason, the whole condensate trap that's just circled here will have to be replaced, because I've actually had people ask me that because they broke a portion of it because they actually used a condensate trap as like I want to say a stool, a step, and it caused them to crush a little bit, and they want to know if individual pieces inside the trap were able to be replaced. The answer is no.
Bill, that's a really good question, because if you compare that to our last Knot XL, the last Knot XL block drain switch is replaceable. You know, we had a separate part for that particular condensate trap, but this is a little bit different. So yeah, that's a good difference between the two.
Absolutely. All right. So let's talk about how we're getting gas to that burner, and what's the combustion system like. So if you're used to negative regulation on the KBNs, this is not going to be anything different. We're still utilizing that blue Honeywell gas valve that everybody's probably seen here and there, and we're also using another gas valve that is nothing new to Lochinvar. So don't be alarmed at all. As far as setting combustion is all done the same way. A little bit different numbers, but it's all done the same way. So the first portion of a neg reg gas train that I like to talk about is just the negative regulation gas valve. So let's talk about how this thing works. So I like to use examples when I'm talking about neg reg and just the components that go along with it. You know, imagine that you have a gas pipe that is piped into the inlet of this style of gas valve, but you have nothing on the manifold or outlet side of it. It's just open. So if I were to hotwire voltage to those solenoids and energize both of them, I would not get gas out on the manifold side of this gas valve. Okay. Would not. Even though I may have 10 inches water column on the inlet side, I still wouldn't get anything out. I have to have a suction, a negative pressure introduced to the outlet side of this gas valve for me to get any type of gas. So you've got a couple of different doors that open. You've got a dual seated solenoid that opens up when you get voltage to the gas valve. And then when you start to have that negative pressure, that suction pressure introduced to the outlet side, it actually pulls open, we'll call it another door inside of the gas valve. That's what actually causes the gas valve to allow gas to exit the valve itself. Not just voltage. You have to have gas, obviously you have to have gas. You have to have voltage to the solenoids, and you have to have a negative pressure influencing on the outlet side of this gas valve. And up here is a pretty good example of this video playing. Right now, we just have air going through the venturi that in a way will be connected to the outlet side of the gas valve. The unit's doing its safety checks, and it powers the solenoids in the gas valve. Now you see gas mixing inside the venturi you see air and gas mixing inside the venturi. Okay. You see that narrowed portion inside of that venturi that causes the air velocity to actually speed up a little bit, in turn dropping the pressure. And you'll see a couple of different styles of gas trains turned up. You know, some venturis are mounted directly to the outlet tapping on the gas valve, and some venturis actually have some piping that connects to the outlet side of it. Either way, that same concept is being utilized. Okay. In a negative regulation gas train, airflow is crucial. The more air you get, the more gas you get. The less airflow you get, the less gas you get. So at the end of the day, that airflow is being influenced by the fan. So whatever your fan RPM is, that's how many BTUs you're driving into the water. So at the end of the day, fan speed on a negative regulation gas train dictates how many BTUs we're pushing into that heat exchanger and pushing into the water. So keep that in mind. Airflow is crucial here when we're talking about all of this. A little bit about the fan. You have two connections that are connecting to the fan itself. You see at the bottom we have a 4-wire 5-pin plug. That's your speed signal. That's your pulse width modulation signal. That's what's telling the fan, hey, I need 5,000 RPMs, or I need 3,000 RPMs. It ramps up to that, and then it sends a proven signal saying, hey, board, I'm at 5,000 RPMs, so we're good to go. And they'll do self checks with one another all throughout the modulation process. On the top portion of the fan that you see in the portion of the wiring diagram, that's just power to the fan. In this case, we're utilizing 120 volts to this fan itself. Okay, so do keep all of that in mind. I'm going to make this quick, but I do like to talk about, fan speed issues happening sometimes. Again, fan speed dictates BTU, so we had to have a way to monitor that fan speed to make sure we're not overfiring or underfiring. And there's a threshold with that. So we look at the board's always looking for the fan to be, if the fan's ramped 20% above set RPMs, or if it goes 20% below, it's going to cause a lockout. That's the threshold. Okay. And a couple things can do that. If I walk up to a unit and I'm dealing with a fan speed lockout, the first thing I'm going to do is see if the fan motor works. Okay. I'm just going to unplug the 4-wire 5-pin plug. I should always have power on the 3-pin, the red, white, and green. So the fan should sound like it ramps up to 100%, because in standby, you still have power to the fan 120, but we're just sending a stop signal saying, hey, fan, don't run right now. Okay. So it should ramp to 100%, or sound like it does. If it does not, and you have power to the 120 side and a good connection, that's textbook bad fan. But if you don't, okay, if you unplug it and that fan ramps up, well, the motor's good. Okay. So we had to have a way to actually test the PWM signal to the fan and the proven signal back to make sure that it's doing what it's supposed to. And here's what we came up with to do so, because you can read pulse width modulation signals out there, but it takes an oscilloscope to do so. And most people don't carry that. And I'm probably not going to be giving out PWM signals to begin with. So we came out with this little fan diagnostics tool to kind of help you with that if you ever need to troubleshoot that. All it does is the whip on the end of this device just goes in series with the PWM signal. You press the test button, we send a signal to the fan, and it checks the proven signal back to this device, and it's either going to pass the fan or fail the fan. Okay. Now, here's the deal. I'm not a salesman. I don't care if you buy this or not. I think it's a good idea to have it available if you do need it, So it's just the way we went to our engineering department and said, look, make us something simple that can shoot a PWM signal and check a receiving signal to check, PWM fans out there on our units. Okay. So keep all that in mind as we're going through it. There's 3 components that make up fan speed issues, and that's the fan, the board, and the harness that connects the two. And always, always, always check those harnesses for bad connections, because I've ran into a lot of bad connections out there, whether that be due to corrosion or what have you. Okay. When it's coming to fan speed issues.
Yeah. I just want to repeat that this is a fan tester. This is not a board tester. A lot of people think that when it says fail, they replace the main control board. No, if there's a red light on this and you're testing with this piece of equipment, it is a red light means failed fan. So it's very important. Just make sure you replace the correct part. That's why it's called the fan diagnostic tool. And John said that we're not salesmen, because we're not, but let's say you're a service guy out there. If someone on this call is a service guy, and let's say your service company has 10, 15 trucks, I don't recommend that you get 15 fan testers and unless you just want to. That's completely fine. That's totally up to you. But I do recommend that you have at least one. So if something like this, if a lockout fan speed error does occur, that you can actually go get the fan tester and take it to that job, and it's going to speed the process up. So at least have one if you're out there.
Absolutely. Something else I do want to add to this. There's one little small caveat to this. In my opinion, and I know Kevin probably feels the same way on this, intermittent units that are locking out intermittently, meaning every now and then they lock out on something, those are the toughest units to troubleshoot. Okay. Yeah. I don't really advise trusting this device if your unit's locking out once a month or every other week on fan speed. When I use this, I'm diagnosing a unit that when I press the reset button, it tries to kick on and it immediately locks out on fan speed. That is when you can put your trust in this device. Again, going back to those intermittent fan speed issues out there, at that point in time, I myself, I'm always promoting redundant units, redundancy out in the industry. That way, if something happens with one unit, you still have another unit to pick up some of the loads. That way you still have heat going out to the system. In those type of applications, I've been known to swap out a fan between the unit or swap out a board between the unit after I've checked my wiring connections, just to see if the problem follows the part or stays with the unit. So that's another route you can go.
I want to say that, it may sound like we're making a big deal out of this, but don't let it sound that way. This is very rare. I mean, right. We just got tired of guessing on our tech service line, because it could be one of 3 things: a fan, a board, or the wiring harness. Well, we can eliminate the wiring harness by just looking at it and testing continuity from one and the other. But when it comes to a fan or a board, if we're having to guess, it's a 50-50 guess. And to be honest, if I had to guess one, absolutely, I would guess fan. But there's no reason to guess. And this lockout fan speed low, fan speed high, lockout fan speed, it's a super rare case that you're going to get this anyway. So just keep that in mind.
Yeah, absolutely. We're always trying to promote not just throwing parts at things, because that does happen out in the industry. And if you ever refer to any of our sequence of operation webinars, you'll hear us really talking about diagnosing the circuit to see what's going on, because not in particular this type of circuit, not with PWM signals, but in a lot of other things, all it is chasing voltage. And when a unit's doing something weird or something, maybe the tech's never heard of, sometimes it can be typical for a board replacement or something to be replaced when it might have just been a loose connection or something. So I try to build everybody up to be more confident in the sequence and how this stuff is working, versus, well, here's some parts, have fun, load your truck up with it, So okay, so this is the style of gas train that we're utilizing on the 400 and the 500, the 400 through the 500. Again, same gas valves we've been using. You will see on this one, though, that we are utilizing a flap style venturi. So you actually have a flap that opens based on a certain low pressure inside of that venturi. That's actually how, we're able to get that 10-to-1 turn down from that 5-to-1 turn down. So that's how we accomplish getting more turn down out of this unit. Okay.
Yeah, that's going to be a difference from the old style Knight XL to this Knight XL.
Yep.
These venturis are going to have flaps in them. And it's not motorized or anything like that. It's gravity driven or suction driven from the fan itself. So it's just a simple mechanical device inside there. It's been pretty reliable to us. We've been using these types of flap valves for a pretty good while now on other products. So we just decided to utilize it on this product to get more turn down. That's it.
Yep. That's
all
it.
The other stuff you see on the screen is going to be just like the Knight XL that you've seen in the past. You can measure incoming gas pressure. You got a bias. You got a throttle. You know how those works. If you don't know how those works, go to those videos online to how to check combustion, and we'll explain all that to you in that video.
Yep, absolutely. And again, you'll see the videos on this Knight, the KBX, come out here probably a couple months. So we're definitely going to get that information to you. Now, when we're utilizing the 650 through the 1 million, same concept, same negative regulation concept we're using here. Everything just gets a little bit larger, right? Most people are probably familiar with this Honeywell style gas valve, so it's nothing new to us or the industry. Now we're also utilizing a similar flap style venturi on this one. Just again, it just gets a little bit larger. So same concept is going on. Here are the combustion numbers that you're going to be trying to target out in the field, but don't get too caught up on getting down to the 10th of a number. Okay. Try to hit these CO2 ranges kind of in the middle. See what your flame looks like. I want a good, strong blue flame. I don't want any noise, burner harmonics. As long as it lights reliably every time it lights and doesn't make any noise from ramping to, high fire to low fire, and your CO levels are less than 150 parts per million, you don't have to nitpick this a whole lot. Just hit it somewhere in the middle of these ranges that I'm giving you. And, I always like to tell people, if you walk up to a unit and the combustion's terrible and it's producing quite a bit of CO, don't just start adjusting gas valves. Check for blockages in the intake, vent, heat exchanger, burner, things like that, because all that stuff is going to influence your combustion not to be so good.
Oh yeah, that's what people do though.
Yeah,
people unfortunately it's easy to adjust a gas valve. Right? I mean, it's super simple, but that's usually not the case. Usually, you might need to get your hands dirty and get in there and clean that unit out.
Yeah, absolutely. I've been to job sites on a unit that's been started up once, has ran one time, and it had a dirty burner because you could run your intake in PVC and nobody deburred all those shavings when they made their cuts on their joints, and all that crap went into the burner. So brand new unit, you had to pull the burner, blow it out with compressed air, and pop it back in, and combustion went right where it needed to. I never had to make a tweak on that gas valve. So I know it sucks, but don't start cranking on valves first. And this is just kind of a summary of everything we just talked about. I'm not going to read each of these individual bullets to you. I'll give you a second to kind of go over it if you need a rehash, venting obstructions and things like that.
Notice the last one there.
Replace the gas valve.
Adjust and replace. Yeah, that I would save that for last. Yeah.
Yeah. Don't start by doing that. I mean, if you want to make some money, you can start by doing it. I'm just kidding. Mark that part up 400 or 500% and have at it, right?
I've seen it. Yeah.
Absolutely. We see some interesting bills come through here at Lock and Bar. So it's whoo. We're in the wrong business, Kevin.
Well, yes, we are.
So on models 400 and 800 only, again, 400 and 800 only, you will have a air pressure switch. It is a normally closed set of contacts, so it actually serves as a blocked vent switch, a blocked flue switch. So if you get a back pressure influence to this switch, it's going to, or a blockage that causes a back pressure, you're going to pop this set of contacts open. Okay. Now, again, we're only utilizing the switch on the 400 and the 800 models. And again, if this contact opens, you're going to see air pressure switch or block vent, block flue come up on the screen. So yeah, we're going to tell you what's going on with it. The burner, I do want to take just a minute or two to go over, you know, how to service that. Again, when you're doing your heat exchanger maintenance once a year, this is something else that's going to be worked into that annual. Okay, I want that burner pulled out. I want it blown from the outside in with compressed air, and you use high pressure on it. You're not going to hurt this burner. Okay, use your high pressure and get all that PVC that you forgot to deburr from your piping out of there. I'm just kidding. Just make sure it's clean, because when you first pull this burner out, it may appear spotless, but when you start to work on it, you're going to see some mess get dislodged and so forth. Okay. Sometimes I have the question, well, John, can I wash this burner out? Yeah, you can wash it out. It's not going to hurt it. It's an Alcro mesh, so it's that woven style carpet that's welded to that burner is basically aluminum and chromium. You're not going to hurt that, but I do recommend still taking some nitrogen or compressed air after you wash it and really blowing all that mess out. Number one, to still maybe dislodge some things. And number two, I don't want a burner full of water going back into that unit.
Yeah, I want that burner dry before it goes back in.
Absolutely.
Yep.
Absolutely.
And clean your flame rods and your igniter. So you know that though, but clean them.
Yep. And or replace them, whichever one you want to do. Yep. So not going to hit too hard on that. You can see that here's the back refractor is a good picture of that heat guard in the back of that heat exchanger. So here's a pretty good cutaway just to give you an idea of what that looks like. As far as sensors go, we're not doing anything different with the sensors here. We're still utilizing 10 and 20 Ks at 77 degrees on all of this stuff. Here's a good picture of the installation of the sensors. Your inlet piping is going to be towards the back of the unit. I took a good left shot of this. So this is your inlet pipe, and this is your outlet pipe towards the front of the heat exchanger. Okay. So you're going to have a 2-wire sensor on the inlet and a 4-wire sensor on the outlet.
Same exact style sensors we use today.
Yep. Nothing has changed. The same resistance scales as well.
Yeah, all of it. Yep.
So inlet sensor is a standard 10K at 77 degrees. So nothing's changed there. If you have an inlet sensor open, come up on the screen, lockout, disconnect the harness from that inlet sensor, check resistance through that sensor. If it's open, replace the sensor. If it's reading 300 ohms, that means that your inlet pipe is the inlet sensor is telling the main board, hey, I've got like an 800 degree inlet, and you probably don't. If you do, you have an even bigger issue and you need to figure that out, or just replace the sensor. I had a guy one time, it was on a water heater. He said that, that was back when I was in tech service. He called, he said, John, I have a big issue. I said, what's that, man? He's like, man, I got 140 degree water going to my toilet, man. Something's wrong with that water heater. I'm like, oh, no, something's wrong with the plumbers. What's wrong?
At least it makes it a warm seat.
Yeah,
right?
yeah, it does. Good and steamy. So on your outlet sensors, you got a dual thermistor here. So you actually have two sensors in one. Okay. You got a 10K and you have a 20K side at both at 77 degrees. We put two sensors in one as a self-check because this outlet sensor on this unit is your controlling sensor. So we had to have a way to make sure that it was reading right. So if those two sensors in one's temperature difference starts to become too great, we're going to lock out on an outlet temp diff. So go back and ohm out each side of that sensor based on the resistance chart in the service manual and see if it's reading wrong or right at that point in time. And here's the chart to go along with that. Back to the flue sensor. Again, this is where we're going to be doing all of our combustion readings. And anytime that you start this unit up, service the unit, do an LP conversion, this is going to have to be removed. The flue sensor and grommet will need to be removed. And this is where you would insert the combustion analyzation probe to take your readings. And here's your flue sensor. It is also a dual thermistor because we wanted to make sure that it always had its self-check, because you do have the ability to vent this unit with plastic pipe, and we got to make sure that we don't get that pipe too hot if something starts to go wrong. And here's the resistance chart here. The 20K side and a 100K side would be troubleshot the same exact way as the other sensors we've been discussing. And I always recommend putting a system sensor on this unit. Connect a system sensor to the low voltage board on this unit and put that system temperature sensor out somewhere leaving the unit. You know, put it on the supply side of the loop somewhere. I want a different point of reference so I can get that system loop up to temp more accurately. And it's a 10K at 77 degrees as well. So if you were standing in front of this unit, in front of the display, you would take the top off of the unit, and on the right side, you would see your control panel. Here you can see we have the same style low voltage board that we've all been utilizing for your thermostat contacts, safeties, all that good stuff. You can see the same style of main control board. And take note here, you will have an extra relay. But only for the 1 million. This is your blower relay, and we had to have a way to isolate some of that amperage, so we're not putting that amperage back on our main control board. And again, we've got our pump relay, so our system boiler and domestic hot water, if you use that as well. We have that integrated into this control panel. Everything's pretty straightforward to get to. And no, we do not ship this little jumper out to you. You will not get that, okay? You have to pay a lot extra to get that little small jumper there. Just kidding. That's just the unit that we were working on, and I completely missed that jumper when I took this picture, and I started to retake the picture, and we're like, makes it look better. I'm good with that. Also, I almost forgot, for my BAS people out there, my Modbus and BACnet guys out there, this, you see these standoffs here, this is where that Modbus or that BACnet card would be mounted inside this control panel, okay? Not the gateway, not the predecessor if you're going that route, just the Modbus or BACnet card.
Yeah, and that's still going to stay an option with these models.
Correct.
Right.
And this is just a good snip of just controls that are going to be, you know, field installed. You can see everything pretty much outside the box here. That's just going to be your louver relays, the tank thermostats, room thermostats, all of that. None of this is changing. All of this is still going to be done the same exact way as we've been doing it on the KBN style units. So don't get worried. Real quick here. The first thing that pops out to me on the screen is, listen, this is a snip of a simulator, so you will not have, the set point range did not change. You are not going to have a 203 degree capability on this unit, I can assure you.
Yeah, just ignore that, please. Yeah.
Ignore that. That's our mistake there.
Yeah. Okay. We had to get this presentation ready for you guys, and this is the screen that we had from our engineering departments, and for some reason it says 203. So yeah, we'll get a better picture.
Yeah. This is not a power fin. Okay. So this is a style screen that you're going to be utilizing here. If you were used to the power fin with the screen on it, or you were used to the Crest or the larger Armor AWH, you're going to have no problem getting used to this. Okay. Well, let's go over a couple of quick things about it. The big two things here, instead of that scroll knob, it's all push button. The big two things here it took me to get used to is, if you can remember, this is your view screen icon and this is your setup menu icon, you're good to go. You're going to have no problem programming this unit, because you can see here, once you press the view screen button, this is what you're going to be able to see. It's all readout from there. So there's no weird symbols. We're going to tell you what all this stuff is and the readout or the input for it. So don't get too worried about that.
Yeah, and if you're not used to these screens, because I know some of our distributors out there, they don't sell the big stuff, and our big stuff is the ones that have the touch screens on it. The programming for this model, like John said earlier, is going to be, as far as parameter wise, is going to be the same. It's just we're putting them on a touch screen for you. It's just going to take a little bit to get used to, but I promise you, we try to make it as much user friendly as possible.
Absolutely.
And it gives you a lot more information, guys. I'm telling you, use this. A lot of people don't use what we give them. It's just blows my mind on what these screens can actually do for you to help you troubleshoot. Use what we give you. Take advantage of it. And before we get going any further, it is 10 o'clock. So therefore we are over on time as of right now. If you have to jump off, we completely understand, just respect of your time, but we will continue going. And if you have to jump off and you want to see the rest of this, we are recording it, and you'll be able to go back on LochinvarU.com and view the rest of it a little bit later if you want to, but we've only got about 8 more slides.
Yeah. So, 5-10 minutes tops. As far as your setup screen goes, whenever you press the setup icon, it's gonna ask you for the code. The code hasn't changed. 5309 still stands. And this is what you're gonna see. You're just gonna scroll up and down to access more parameters, because you can scroll this tab up and you will see more. And then now we're back to here. You still see your same old SH1, SH2, SH3, HW. Now you're scrolling a bar instead of rolling a knob to change it. Once you've made your set point, whatever you want it to be, hit apply changes, and it's going to update the control. That's how you change parameters. The difference in sizes here, we added that 650 on this KBX style to take place of the 600 and the 700 that we had in the past of the KBN, and we added the 1 million BTU model. Okay, so in sizes, that's your differences there. One other thing that we added in was an integral filter. So once a month, I want this thing looked at, though. Take it out once a month, look at it. Is it dirty? If yes, replace. If no, pop back in and keep rolling. Okay. Couple things about it. I don't want any pleated filters because they create too much restriction, and I want that MERV to be 4 or below. Okay. We're catching the big stuff: leaves, squirrels, anything like that. So
rats, birds,
birds, frogs, crawfish, all that. I'm just kidding. So just the big things. But at the end of the day, the burner is that ultimate filter. And here's the size for all models down here at the bottom, 1x12 by 12.
And just for you guys out there, just because you have a filter does not mean you don't have to clean this unit.
Correct.
A lot of people think the filter, I've got a filter, all I gotta do is change out the filter. Nope. Sorry, still gonna have to get in and clean that burner.
Absolutely. The venting differences, we already went over the equivalent feet difference: 150 on the new one, 100 on the old one. You still have to take into account the 5 feet per elbow and 3 feet per 45. You will notice on the chart on the next page, the intake for the 800. If you want 150 equivalent feet, you will have to upsize that 2 pipe sizes to accomplish that. But the vent can be left the same size to achieve that 150 equivalent feet. And I'll show you that here in just a second. So down here at the 800, you see, if you want, you can still go up to 100 feet if you want to utilize 4-inch on your intake. But if you want the 150, you're going to bump that up to 6-inch and then take over that extra footage that you needed to accomplish. As far as the vent goes on the 800, it's 6 inches goes, 100 feet or 150 feet, whatever you want to do there for that point. Gas conversions on the KBN style, the old Knight, the 501 and through the 801, it was just a gas valve adjustment and then setting combustion. Okay, that's it. But for the 400, you had to add an orifice into that to go from natural to LP. Okay, and then obviously we would check combustion. On this one, it's just a little bit different. On the newer style, the big difference is on all models, it will require a Venturi replacement, a Venturi change. So if you need to go from natural to LP, you're going to be replacing the Venturi with an LP style Venturi. But note, on the 500 models, and the 500 model, and this is the only one that requires it, you will have to install that O-ring, that orifice, only on the 500 though. Okay, so all models, Venturi change, and add an orifice on the 500, and then check combustion. And a little side note, if you've been running 7 months and for some reason they're changing from natural to LP for whatever that reason may be, I'd recommend service and clean the heat exchanger and burner like we discussed before you fire this unit up. And again, I promised you a picture at the beginning of this presentation. This is what the outdoor KBX will look like. Again, indoor cannot be converted to outdoor. This is what you will get. So if you were used to the AWH style unit, it looks exactly the same except smaller. Okay, this is your outdoor version. I know that was quite a bit of information. We only went 5 minutes over, so I feel like we did pretty good. I really hate to rush through some of that because I feel like I was just a little bit, but we're on a time crunch. So whenever we do get our classes rolling again and, we get our guys, contractors and engineers and everyone else coming back in, we can really take the time to elaborate as much as you want to. Okay. So, or if you have any additional questions, feel free to ask me now, ask us now. We're going to be on here for a couple more minutes, just answer any questions if you have it. And always feel free to shoot us an email at training@lockandbar.com if you